It is often argued that market failures will create a need for government intervention. And this is true, but we also have to discuss whether the government intervention itself is worse than the market failure. So, for example, if you have a list of market failures here, you have externalities, or you have monopolies, natural monopolies, or you have public goods. Now, for all of these cases, it's possible that the government could intervene and do something. The question is, could something bad also happen when the government intervenes? We have to talk not just about the market failures, but also about the government failures, and that's what we're going to do in this brief lecture. And I think there are two kinds of government failures that we need to discuss. First of all, we need to discuss whether there is enough information for the government to intervene. They have to have enough information in order to make the intervention optimal. And the second thing is we have to argue that not only do they have to have the information, they have to have the incentives to behave or to act on the information in an optimal way. So these are the two things we should discuss. Let's talk about information first. So what kind of information problems do we have when we try to intervene on behalf of, try to act on a market failure? Well, first we have to decide, for example, how much to provide of something. Let's say it's healthcare, and we make the government responsible for healthcare, and then the government has to decide how much money should we allocate to healthcare. And the market is taking care of it by itself, because people decide how much money to spend on it. But once the government is going to provide it, they have to decide how much. Now, usually this is decided in the political process, how much to spend on different things. The problem with the political process in this case is it could give you the wrong answer. So one information problem here, and this is illustrated by a theorem by Arrow. And I'll just give you one brief example. Let's say you have to choose between money to a library, or a pool, or a bike lane. And let's say you're part of a committee with 3 people, or a community of 3 people. And person A has the following priorities: library first, second pool, the third bike lane. Now the second person, person B, has the following priorities: library in second place, then the pool, and the bike lane first. The third person, person C, has the following priorities: library is in last place, next pool in first place, and then bike lane. Now ask yourself, if you put this to the vote and try to find out what's the general will of society in this case, will they choose pool, library, or bike lane? Well, if you aggregate the preferences of all these 3 people and try to select between library and pool, then library and pool, library A votes for library and B votes for library, so library wins. So now you have to choose between, and you forget about the pool, now you have to choose between library and bike lane, and you can see that bike lane is preferred by B and bike lane is preferred by C, so the winner is bike lane. That's what we're going to do then. It seems like the general will of the population is to choose a bike lane. Now the problem is, of course, that let's choose a different order of voting. So you choose between a bike lane first and second library. So that's your choice now: bike lane, library. And then bike lane is going to win. Fine. Next, choose between a bike lane and the pool. The pool will win here, and the pool will win here. So now pool is going to be the selected project for this community. So you see, whatever you're going to do here depends on the voting order. And this exemplifies a problem with the democratic process of selecting how much you're going to do or what you're going to do in society. Of course, this is just a small technical problem. It may not be a big problem in a large democracy, But it's just one example of a problem, and there are many more problems there. Now, another information problem that is perhaps even more serious is illustrated by the problem of trying to determine the optimal tax rate. So let's say you try to determine the optimal tax. That's the second information problem I want to discuss, optimal tax rate. So let's say you have something and you know it's causes an externality. So you want to put a tax on it in order to make the amount produced optimal. Okay, so put a tax on it. The question is then, how big should the tax be? Well, then you try to calculate the external cost and things like that, and you say, okay, let's say the external cost is $5. That's going to be the tax as well. No, because you have to take into account the connection between this product and all the other products. And I'll just give you one brief example. Or I can give you two examples here. Let's say the product you're looking at is X, and you know you should put a tax of $5 on that product, for example. Now, X could be related to another product, let's say Y. And let's say X produces a negative externality, but Y produces a positive externality. And let's say the two are complements, for example, meaning that if you get more of X, you also get more of Y. Now, if you put a tax on X, then you will reduce the negative externality associated with X, so that's fine. But since Y is a complement, you will also reduce the positive externality because you reduce the consumption of Y and the positive externality associated with that. So now you have to balance the two. You can't just look at X in isolation. You have to look at how is X related to all the other products in the economy. Is it complements? Are they substitute? How strongly are they related? So what will happen to the consumption of all the other goods in the economy? So the information required in order to put an optimal tax on X is very large. You need a lot of information. You can't just look at X itself. So that's a big problem when you try to have government intervention and put a tax on things. And this could be generalized into something called the theory of the second best. Now, the theory of the second best simply says that if you have a lot of conditions that have to be satisfied for the optimal point, then let's say condition 1, condition 2, condition 3. So let's say condition 1 is you have perfect competition. Condition 2 is you have no externalities. Condition 3 is you have no public goods. Right? Now let's say one condition is not satisfied. Let's say, for example, it's impossible to get rid of the externality for some technical reason. There's no way you can do anything about that with government intervention. So this condition cannot be satisfied. Then the theory of the second best says that in general you should not strive to satisfy all the other conditions and then, so to speak, try to get as close as possible to optimal point. No. When one condition is not satisfied, all the other conditions will fail or will change. So in this example, for example, if you have an externality, then you may not even want to try to create perfect competition, because maybe a monopoly would be good then, because if you have an externality, a monopoly will produce less goods, so you will have smaller externalities. And trying to move to a situation with perfect competition, then you will have lower prices and more goods produced and more externalities. So it's a balancing act, of course. You have to change the optimal conditions for all the other factors here. When one condition is not satisfied, everything else changes. And that's the theory of the second best, and it really tells you that you need a lot of information in order to create optimal solution to something. It's not enough to look at one condition isolated. So these were two of the information problems you have. One is to aggregate information from in order to know how much you want to produce of something. Technical problem there was arrow. It may not be a large problem, but this problem here, how to find the optimal tax rate, and even more the theory of the second best, tells you that you often need a lot of information in order to create optimal or good government intervention. Now, information is just one problem, of course. The second problem I mentioned here was incentives. So even if you have the information, why can you assume that the government will actually act on that information? Because they have different incentives. In a market economy, the company will have an incentive to maximize profit. We know that, and that's what we base our proofs on when we do the math that the market economy will work given certain assumptions. But the government, we can't just assume that they will do the right thing. And there are at least two things there we have to consider when it comes to incentives. First, you want to look at the incentives of politicians. And in general, I think we have to look at two groups when it comes to incentives problems. First of all, you have to look at the politicians. And in the market economy, you know that the interest of the company is to maximize profits. When it comes to the government, the interest of the politicians is to get re-elected. And to get re-elected, they may not necessarily be interested in acting on the best or the information they have here. The second thing would be the bureaucrats. And once again, they have certain aims, and these aims do not necessarily coincide with what's the general best action in society. So one example could be what they call regulatory capture. This simply means that people who actually are put there in place to regulate a private firm, for example, they may have different interests than just regulating them. They may, for example, want a job in that firm, so they're going to be nice to them in order to get a job there. Things like that. So even if they have good information, the actors in the government may not act on that information. So we have to consider both these problems, just both the information problem and the incentive problems when we try to create some kind of optimal regulation. Thanks.